Okay, so far we know, I'm gonna really highlight these so that if I was looking back at my notes, I would see those two sticking out. We know that the square root of -1 is I. We talked about how to break them down, put an I on the outside if needed. And then if you square an I squared, you get back to -1. So, did you or did you not do this with Mr. Thorson?
We did.
We did, okay. But not necessarily remembering it forever, huh? All right, let's try again. Example 4. All right, do you guys know the properties of square roots? What if you have the square root of -7 times the square root of -7? Do you guys know what you can do with the stuff on the inside if you're multiplying the square roots together? Yeah, you can multiply them on the inside too. So the square root of -7 times the square root of -7 is the square root of a positive 49, because a -7 times a -7 is a positive 49. So what's the answer to this problem? 7. Yep. And you can go back to a -7 if you were doing something like solving for an x, because it could be 7 or -7. Example 5. What if it was this? The square root of -6 times the square root of -10. Go ahead and try this one with your partner. I'm going to give a prize for this. You're right, it is the square root of 60, but then you have to break it down. Talk to your partner. Human words. While they're working, I'm going to slide back up here and tell you guys that since it was negative under a square root, that's why there's an I right here, because the square root of 16 is 4, but the negative under there makes the I. This one, if you break it down to 7 times 10 and then 2 times 5, none of these are in pairs. So I am going to put that I on the outside, but then there's still a square root of 70. And this one we broke down and took 2 pairs out of, which is where the 4 came from. And then the I is the negative there, and then the square root of 3 is because there was a 3 left over. All right. So who's up for this? One, 2,
Wait, is this a group then?
3, 4, 5, 6, 7, yeah. And yes, there is an or, and the reason why is because you could see that the original problem had negatives underneath it. Could be a negative or a positive when you're simplifying. Group 3. Jackson, are you speaking? Can you speak over here by the...
It got really loud when was Tanner speaking on the video?
Yeah, he was really going for it.
Yeah.
Yeah, he did.
Alright,
Very
so
loud.
first thing you do, multiply together, 60, break it down. It's going to be 5 and 12. Then we're going to break that down, 2 and 6, break that down then, 2 and 3. Circle your, yep, and then you're going to put the 2 on the outside, and then 5 times 3 on the inside, and that's it.
Sure, and it also can be -2 times the square root of 15 because it was originally negatives to begin with. Okay. All right.
Do that for like every problem set?
If there were negatives to begin with and you could see it, yes. If there weren't, what?
Do they have to be negative?
Yes. Yeah.
It would be negative.
And if one of them was negative, then there'd just be an I in the answer. What?
Would it be negative 2 on the outside, or negative 15?
-2. All right.
What difference is between a -2 or 2i?
There would only be an I there if there was only one negative, because the 2 negatives kind of ended up working each other out. All right, Jackson, you promise you're not going to bounce that in other people's classrooms? You're not going to promise?
No.
Okay. All right, example 6. Let's do the square root of negative 48 divided by the square root of 24. Anybody have an idea of how this is going to work out? Did you get an M1 sign, Natalie? Okay. Anybody want to take a guess of what we're going to do with this? Yeah?
We're gonna break it down and then we're gonna cross out.
This stuff we can cross out. Okay, now see how this only has one negative here though? So that's going to be an I. So I'm going to do my work down here a little bit. So let's see, I'm going to break down 48 and I'm going to break down 24. Yes?
Why can't you just do what you did with the multiply and just do it together and it'll be 2? It'd be like,
You actually could do that. You could, yeah, you can do it that way. You could just divide them out. I was going to go with Kyle's suggestion of canceling out what we could, because that's also a way to do it, but you're right, it's way faster to do it the other way, so we can try it that way too. 48 divided by 24 is what? 2? But here you would have to have an I involved, do you know why? There's only one negative there, yeah. If there were 2 negatives, then you'd have this thing where it's either or. Okay, if you were to cancel them out this way, it'd be like 12 and 4. And I want to remind you that you don't have to break it down to the smallest thing. Do you see how right now I have a pair of 4s already?
we're supposed to break it down.
Well, you can, but you can also break it down until you have pairs. So like, for example, if I was to break these down and it was 2, 2, and 2, 2, then I'd have a pair of 2s, right? So my outside number would be 2 times 2, which is 4. Or I could just have one pair of 4s and my outside number is 4. You see, like, it's just, you can stop yourself before you go all the way. Caitlin?
Well, the first one didn't always work.
Yes. I'm just trying to show you multiple ways if you prefer something else. This one is 2 and 3, that one's 2 and 2. So what there's left over? Got a pair of 2s? Am I missing something? 2 and 3. So we should get, yeah, okay, so we have 4 times 4i times the square root of 3 over 2 square root of, is that on the bottom, 6? And then, wait, was it a 2 on the bottom? No, it was on the top to begin with. So this divided by this, oh, I must be missing something.
What's it supposed to equal?
They're supposed to cancel out, our square roots are supposed to cancel out, and 4 divided by 2 is 2, so that one works out, right? So I should have the square root of 3 and the square root of 3, or the square root of 6 and the square root of 6. That's how it should work out. Did I mess up some simple math here? Does anybody catch it?
On the 24 side,
Yeah?
you did the 2 and the 3, but you never multiplied the 2. Oh, you didn't.
Yeah, they're here.
Can you just cancel them out right there?
Cancel what out right there?
Like, can you just cancel all the 2s and 3s and then you're left over with the square root of 8? Or is that not right?
The square root of 8.
Is that right or no?
Where did you get the square root of 8 though? I just don't understand.
Is that the answer?
No, the answer is 2i.
Well, one minute.
Oh, I didn't
So
cancel
here's what it
everything
should
out.
be. It should be, do you see how we have 4i divided by 2, right? And 4 divided by 2 is 2. So that takes care of the 2i, but we should have stuff that's canceling out here almost equally, yeah?
Okay, so like, for the like 3 and 6 square root, when it just like these you take out, like 3 or whatever.
A 3 from the top and the bottom, right? But there shouldn't be anything left over down here, Morgan.
If you redo like the branches from the 24 and the 48, if you do 48 and 4 and 12, it gets a pair of 4s and a 3, and then if you do 24 and 3 and 8, you get a pair of 4s and a 3.
So instead of doing 4 and 6, what did you do?
I did 3 and 8.
Doesn't it break down to the same?
It should be the same.
But it's still the same because it adds up to 4 to 8.
You just pick out the books, dog.
No, it can't.
What's the answer in the book?
It's 2i.
Oh, well,
But then,
Oh,
how
that's
would we
still
not
just-
get it breaking it down?
Divide it together.
I think Jackie's way is superior.
Yeah, just do simple math. Yeah, that's
Okay, I'm gonna check on this and I'm gonna get back to you. We're gonna move on to the easier stuff.
Alright, I have another question.
Yes.
So could you cancel out the square root of there? Cause the 6 breaks down to a square root of 3 and a square root of 2.
You could. And then you'd have a square root of 3 that you cancel out on both of them, and you'd have a square root of 2 left over, but it doesn't equal what we got before, so I'm gonna think about it, yeah?
So, you know how it was like -48 and 24?
Yeah.
And if you did something not equal to decimal, could you still do like 1.3i? Or is that disgusting in that?
I mean, you can have a decimal, but not if it's in the square root. You wanna